Struggling with maintainable code? You're missing a vital pattern. Why do you unconsciously avoid it? Let's analyze the problem. Intro music fades. Struggling with maintainable code? You're missing a vital pattern. Why do you unconsciously avoid it? Let's analyze the problem. Okay, let's be honest. How many times have you stared at a code base, maybe even one you wrote, and thought, how did this become such a tangled mess? You're not alone. Studies show that developers spend roughly 60% of their time maintaining existing code, not writing new features. That's a huge chunk of effort. And a lot of that inefficiency stems from a fundamental gap in how we learn and apply coding patterns. The pattern I'm talking about isn't some obscure design pattern like the visitor or the flyweight. Those are important, sure, but this is more foundational. It's about how you structure your logic within your classes and functions, a crucial layer often skipped in introductory tutorials. It's the what of coding, not just the how. And senior engineers, well, they don't explicitly teach it. My first revelation, the problem isn't complexity, it's exposure. Most coding tutorials focus on building things. You learn to create a button, a form, a data structure. But they rarely delve into the internal organization of complex logic within those structures. Think about how you learned loops and conditional statements. You built a simple program to print numbers or calculate a sum. Great. But how often were you shown how to break down a complex business rule? Say, calculating insurance premiums based on age, location, driving history, and vehicle type, into manageable, testable chunks inside a function. Let's look at a real example. In 2015, a critical bug was discovered in the Java virtual machine at Oracle, impacting millions of applications worldwide. The bug, dubbed JAXA, was traced back to a highly convoluted function responsible for handling certain security protocols. The function spanned over 400 lines of code, intertwined with multiple nested loops and conditional statements. Post-mortem analysis revealed that junior developers, facing immense pressure to deliver features quickly, had layered functionality onto this existing behemoth without properly refactoring it. The lack of clear, modular structure made debugging nearly impossible. The fix, when it finally arrived, was a complete rewrite, taking nearly a month and requiring significant overtime. It wasn't a lack of knowledge that caused the JAXA bug. It was a lack of exposure to, and practice with, clean internal code organization. We're taught what to build, but not necessarily how to structure the gears within that machine. Brief pause, subtle background music change. But that's not the strangest part. This isn't just about individual functions becoming unwieldy. It's about how this habit permeates entire architectures. Let's move to a deeper layer, the feature factory syndrome. Many companies, particularly in the early stages of rapid growth, fall into what's known as the feature factory trap. They prioritize adding features over code quality. The focus becomes get it done, not get it done well. This often leads to sprawling classes with hundreds, even thousands, of lines of code. These classes become repositories of everything related to a specific feature: UI logic, data processing, business rules, all crammed together. Consider Netflix. Early in their growth, before their extensive microservice architecture, their codebase was notorious for its monolithic nature. Stories abound, though often anecdotal, of developers being afraid to touch certain modules, fearing unintended consequences across the system. While they've since embraced a more modular approach, the legacy of that monolithic past continues to influence their engineering practices. Their current system, even with microservices, is still incredibly complex and requires a deep understanding of the interconnectedness of its components. And that complexity isn't inherent to the features themselves, but to how those features were initially structured. Why does this happen? It boils down to cognitive load. Breaking down a complex problem into smaller, manageable pieces requires more upfront thinking and planning. It's easier, in the short term, to just tack on functionality. But that technical debt accumulates rapidly. Slightly faster pacing in the narration. But that's not the strangest part. It's not just about the immediate consequences of poor code structure. It's about why we avoid the solutions in the first place. This brings us to the twist nobody expects, the psychology of good enough. We, as humans, are wired to seek efficiency. We want to solve problems quickly. Learning and implementing clean code principles, like the single responsibility principle, dependency injection, and clear separation of concerns takes time and effort. It requires constant questioning and refactoring, and that's uncomfortable. It challenges our immediate desire for completion. Think about it. How often have you convinced yourself that good enough is sufficient? That refactoring can wait until later? That the added complexity of a design pattern isn't worth the effort for a relatively small feature? It's a natural human tendency to prioritize short-term gains over long-term maintenance. Even at Google, a company famed for its engineering excellence, this phenomenon exists. Internal documentation, often circulated among engineers, candidly acknowledges the struggle to maintain a consistent level of code quality across all teams. There's a constant tension between speed of delivery and long-term maintainability. A 2019 internal survey revealed that nearly 40% of Google engineers felt pressure to prioritize feature development over code quality. That's a staggering number, even for a company with Google's resources and engineering expertise. The problem isn't a lack of tools or training. It's a psychological hurdle. We're avoiding the crucial pattern, the pattern of disciplined code organization, because it's hard, because it forces us to confront our own cognitive biases and our ingrained desire for immediate gratification. Sound effect, a subtle, echoing click. Okay, so how do we overcome this? Let's move to the conclusion, the power of microhabits. You don't need to rewrite your entire codebase overnight. The key is to cultivate microhabits. Start by refactoring one function a day. Focus on making it smaller, more focused, and easier to understand. Practice writing unit tests, not just to verify functionality, but to guide your refactoring process. Force yourself to explicitly apply the single responsibility principle. Each function should do one thing, and do it well. And, critically, talk about it. Discuss code structure with your colleagues. Ask for feedback. Share your struggles and your successes. The more you vocalize the importance of clean code, the more you normalize it within your team. Create a culture of constructive criticism, where code quality is valued as much as feature delivery. Remember the JAXA bug at Oracle? The fix wasn't just about rewriting a function. It was about changing the culture of code development. Introducing rigorous code reviews, mandatory refactoring sessions, and a greater emphasis on long-term maintainability. And here's a challenge for you. This week, choose one piece of code you've written. It doesn't have to be huge, and deliberately refactor it using the principles we've discussed. Even a small improvement will make a difference. Track your time, note your frustrations, and celebrate your successes. Music swells slightly. The code pattern senior engineers don't explicitly teach isn't a secret weapon, it's a mindset.